Morning. I figured this was it's a dangerous question to ask to a sensors crowd. You know, have we reached peak sensors? And just wanted to maybe emphasize this. So on my body right now, this is the list of sensors I am currently carrying. Okay, if you actually take an inventory of just how loaded I am from a sensing platform standpoint, I'm pretty loaded. And actually, everyone in this room is pretty loaded from a sensors standpoint. These are all billion unit a year markets. Okay, I mean, what's amazing is that these three platforms did not exist 10 years ago, or 15 years ago now. Okay, the earbud market has grown from nothing to 500 million units a year in roughly 5 years, give or take. Okay, and so the challenges we're facing at this point are, if you've ever looked inside of a phone or looked inside of an earbud, it's looking like a watch. Okay, I mean, you want to talk about how intricate and how every last square cubic millimeter of space has been packed. It's packed. So right now, the bar for integration for new sensors is extremely high. Okay, speaking as, you know, from the Google perspective, yes, I mean, we obviously produce phones. The bar for sensor introduction is really, really high. So where do we go from here is the question, right? How do we get new sensor technologies in? How do we expand the user experience? You know, the whole size, cost, power thing is that it's real, okay? we'll just leave it at that. So sensor reuse becomes key. How can we fuse? How can we reuse? How can we find new ways of using the sensors that we already have? Okay, and so that's kind of the topic of my talk this morning. So where do we go from here? There are three areas that I see that are super interesting going forward. Okay, one of them is ambient. Okay, so how do all of the phones, the platforms continuously monitor the world around them? Okay. Second one is health and biometrics. Health is growing rapidly as kind of an area of interest from a sensor standpoint. Everyone's worried about their health. Okay, so this is something where, yes, we're going to see more and more of this showing up actually in our devices. Biometrics, hate to say this, our lives are on our phones now. So security is increasingly of concern. Having said that, you can make your phone super secure. It also could take you 10 minutes to get into your phone. So, you know, how do we increase biometric security without costing the user friction in terms of getting into their device, right? There is a huge trade-off between how secure your device is and how much friction there is to get in. As I said, actually, the most secure phone in the world is the one no one can get in, including you, okay? So health and biometrics. And then the last one is extending the HMI, right? Devices are getting smaller. How in the world do you improve the user experience, actually? How do you increase the interactivity, actually, with the device? The flat slab smartphone has been with us for 15 years. It's super effective, okay? The touch screen is the default interface. How do you extend that? Okay, and so, you know, beyond touch is actually a really interesting topic of discussion. So I could actually spend days talking about any one of these. I will try to walk through sort of some highlights in the next 15 minutes or so. So, ambient. So again, it's about understanding the environment around the user. It is continuously sensing. So this is one of the really interesting requirements, okay? So your power draw has got to get down into the microamps, or you're reusing stuff that already is drawing power in the system. This continuous sensing requirement, what we call longitudinal sensing, okay? You're talking about basically a sensor that's active continuously. Unlike other sensors that are active on demand, an ambient sensor actually would have to be running 100% duty cycle all the time, all day, every day. What do we do from a power standpoint, okay? The trend that we're seeing is that we are basically turning existing radios into radar-like scanners. That seems to be the trend here. So 802.11, 802.11bf, also known as Wi-Fi sensing. You can think of it as that any radio system right now has got to understand how the radio waves are reflecting off of objects, okay? Off of walls, off of people, off of things moving around in the environment. As I'm walking around, every one of our phones is equalizing its Wi-Fi response, okay? So the concept behind 802.11bf and Wi-Fi sensing is you're looking at the channel state information of the Wi-Fi receiver. Okay, so you're asking, fine, as over time, what's the evolution actually of the equalizer profile in real time? Okay, and the Wi-Fi chipsets out there are starting to support this. Okay, on the right, at the bottom, so you can see that, yes, we're looking at how the waves are bouncing around the room, bouncing off of people, objects, things like that. This is a plot of, so the vertical axis is the channel state information, the x-axis is time evolution. Okay, just to give you an idea, this is no motion, so no change. This is someone walking in the environment. This is someone turning around. This is someone sitting down. Okay. So just by looking at what the radio is doing, I can basically tell you what's happening, right? Is somebody sitting down? Is somebody turning around? Is there somebody coming up behind you? This is all possible, okay? And so this concept of turning a radio into a sensor is actually really intriguing, right? Because your Wi-Fi is continuously connected. It's beaconing all of the time, okay? So there's a very rich area of algorithmic development that's happening actually around this whole concept, okay? You can imagine with the coming of millimeter wave FR2 5G radios, right? See, 802.11 right now, you're restricted to roughly, 5 gig, it's about 1/5 of a meter in terms of wavelength, right? So your resolution is, it's okay, 20 centimeters. Up around 40 gigahertz, your wavelength is way shorter than that. So your ability to resolve very, very fine motion actually using the FR2 radios, that's an area of active research right now. Okay. Bluetooth ATOM. So again, you want to talk about wide deployment, Bluetooth is everywhere. Okay, so the concept of high accuracy distance measurement is actually been part of Bluetooth Low Energy for a while now. We're starting to see this coming more and more actually in terms of first application is car keys. So determining ranging distance, to your vehicle before authentication is critical. So Bluetooth ATOM has seen early adoption actually in the car key space. You can imagine that this is going to start accelerating. It's really, you can think of it as yes, we've heard a lot about ultra-wideband in the last couple of years. Ultra-wideband is great. It's going to take a while before it gets to ubiquity. Bluetooth is already ubiquitous. So how in the world can we leverage Bluetooth more because it's already there? Change the protocol stack to basically provide us positioning information. So the other really interesting thing is that folks are now talking about angle of arrival and angle of departure actually to beacons using Bluetooth. Yes, it does require an antenna array, but believe it or not, your phone is about the right size actually to do it. Okay. So Ambient. So this is the sort of things that we're seeing actually from a sensor standpoint. This concept of using basically our existing radios as radar devices, as sensors. On a health and biometrics front, again, a lot of really interesting research actually happening here. So you want to actually provide longitudinal health metrics. Now, this is longitudinal in the sense that, yes, I'm going to take someone's blood pressure or look at their SpO2 maybe once a day, maybe every 10 minutes. So it's not necessarily continuously longitudinal, but it is on a much, sort of a much longer basis than, let's just say I have to sit down, put on a blood pressure cuff, and then do this maybe once a week. My doctor tells me I should do this. Okay, I don't. So as I mentioned earlier, multi-factor biometric authentication actually is a really interesting area because we can improve the sort of security of our devices, but because it's actually being sensed passively, and we'll talk about what exactly that means, basically there's no friction. Okay. So some novel health sensing modalities. Okay. Blood pressure. So this is a super interesting one. So sort of the blood pressure sensor that you're starting to see deployed, Samsung actually put one into their Galaxy Watch 4, something, and it uses this technology called pulse transit. It's a reuse of ECG and the PPG sensors actually that exist in the watch already. And it's a fairly simple concept. What you're looking for is the time differential between when your heart squeezes to the point that the pressure wave actually goes underneath the heart rate sensor. Okay, so you're looking for the time difference between the peak of the ECG, which is when your heart contracted, to the point where, yes, the blood pressure wave actually finally hit. Okay, unsurprisingly, this is subject to, tissue density, how atherosclerotic or not sclerotic your arteries are. There's a bunch of variables that actually affect the accuracy of this measurement. Okay, so currently it requires the cuff calibration. There's a lot of work around machine learning to actually eliminate the calibration actually and do this kind of as a ground truth kind of sensor for blood pressure. And again, this would be something that, yes, I could do every day or every few hours. So long as I'm sitting still, I can take the ECG and your watch will compute what your blood pressure is. Non-invasive. Okay, the other one that's interesting is, especially in the age of COVID, in-ear core body temperature. So this is from Huawei. The Honor Earbuds 3 that just launched, they actually have a contact high accuracy temperature sensor actually embedded into the earbud actually for health. So you can imagine just being able to just monitor if you got a fever going or not. So you're starting to see that the earbud itself, because it's in your ear, it's a prime location to actually sense sort of your health, right? And body temperature is kind of just the beginning of it. The claimed accuracy right now is like 0.3. Kind of one of the holy grails is to get to 0.1, where we can start talking about women's health, ovulation, sort of being able to sense modalities actually at that level. Okay, so again, health is a really interesting and growing area actually in these devices, and it's just a lot of sort of just innovation around algorithms, innovation on we've got enough room to actually integrate a high temperature, high accuracy temp sensor actually into a hearable. So multi-factor. So these are secondary biometrics. As I said, we're talking about improving the security. Your phone, your device recognizes, yes, you are you. Simplest one right now is your Apple Watch directly unlocks your phone, right? You're assuming that you're wearing your watch all day. If you've authenticated into the watch, we'll use that to authenticate into your phone. Fine, that's great. How can sensors help? Okay, so secondary biometrics are sensing other characteristics of you being you continuously. So gait analysis, so you're looking at, your phone's in your pocket, the IMU's running, we're already computing how many steps you took, your watch is also computing that. If you actually look at, sort of the way you walk, it turns out that with machine learning techniques, you can actually group, users pretty well, actually based on, their walking patterns. Now, whether or not you've had a few drinks or not, yes, things are going to change, all right? Having said that, an ML classifier, this is ML classification around 114 users, okay? There was another startup that I'm familiar with that actually did this work. So you can see actually from a clustering standpoint, it's pretty distinct, okay? So this is actually a pretty solid measure that, you are who you are, right? If the gait of whoever grabbed your phone is not matching up, it's not going to authenticate. It's going to demand either a PIN or something beyond just like a fingerprint. It's really about augmenting security without costing the user any more effort than what they're already experiencing. The other one is that we just use the current speaker microphone in your earbud to launch acoustic pulses above the 20 kilohertz band. So you can't hear them. But if you look at the echoes of that pulse in your ear canal, you end up with a very distinct signature per user, okay? So ear canal signature actually is something, look, I'm wearing earbuds. I am, thanks to COVID, I've worn my AirPods more than I care to mention. It can continuously monitor that and validate that, yes, I am who I am. Okay? So again, these are secondary authentication metrics, sensors based, that can continuously monitor and validate that you are who you are. Okay. Extending the HMI. So how do we go beyond the flat touch interface that's dominated for the past 15 years? So beyond touch, it's really, the way, if you think about, and this is an area I can get particularly passionate about, so forgive me. If you think about the way we use a TV remote and the way we use a smartphone, it's actually two very, very different use modalities. If you think about the way you use a TV remote, you never look at the buttons. You know exactly how to change the volume, how to change the channel, and you never involve the visual cortex. From a mental sort of thought standpoint, you never actually look at the remote. You actually just, you do it entirely by haptics. You feel your way around that control, and muscle memory drives everything else. Your phone, actually, on the other hand, requires actually fairly active involvement from your visual cortex because you have to look at the thing, basically go aim at whatever, the OK button, okay? So beyond touch is really HMI actually without requiring visual interaction, okay? And yes, we've had some fits and starts around force sensing, but if you also think about how humans actually use touch, how hard you're pushing is actually a major input variable to you as a human, okay? The extent that our phones are not really taking advantage of that as an input variable, it's something that actually has to be reckoned with. And so just think about the buttons on the edge of your phone, edge sensing. So my last startup was actually heavily involved actually in this area, okay? So capacitive multi-touch works great on nice flat planar surfaces on an insulating substrate. So we've actually demonstrated that ultrasound actually can be used as a touch everywhere solution. Coming back to millimeter wave and all that, something? To get to a millimeter wave sensor in ultrasound, you only need a carrier wave about 1 megahertz, okay? We talk about millimeter wave sensing because guess what? The speed of light's too high, so you need to actually operate around 60 gigahertz to get a sensor wavelength short enough to be really interesting from a human interaction standpoint. Ultrasound, you can get to 1 millimeter wavelengths actually in aluminum or steel or titanium substrates, by basically operating around 1 megahertz. And from a low power, high integration standpoint, I can do a lot of damage actually at 1 megahertz, okay? 60 gigs much tougher, speaking as a former radio guy. The other really interesting thing about ultrasound is that it can actually sense force actually in addition to position, all right? So, the way the system works is it's a MIMO system. You have got transmitters and receivers along this, embedded along the edge of your phone, and it's launching ultrasonic pulses. And what's happening is you're looking at, fine, I have a time of arrival of an interference pulse when a touch occurs. So your time of flight actually will determine your position. Intuitively, that kind of makes sense. Your finger came down, it introduced a new reflection, great, I'm gonna measure how much time from one transmitter to that reflection point, that tells me where the touch was, great. The really interesting thing is that how hard you're pushing changes the coupling between your finger and the surface you're contacting. So we can actually measure force by looking at the amplitude of that disturbance. So the harder you're pushing, the bigger that pulse gets. And it turns out it's linear. So what's really cool is you can end up using ultrasound as a kind of a touch anywhere solution because it's not dependent on electromagnetic kind of fields, right? A capacitive touch sensor requires a capacitive field, which means it doesn't work on metal. Okay, but this is a mechanical sensor. You're looking at a mechanical vibration, sort of traversing through the surface of whatever you're trying to sense, and you're looking at the interference as touches occur, okay? Here are the use cases. So it's gaming phones. So what you end up doing is you end up introducing PlayStation-style controllers when someone's playing, a landscape mode game. This is actually important for the coming of cloud gaming, right? So you think about, Xbox and PlayStation, you think about all of the cloud gaming services that are coming online. The whole premise is you are going to bring the console or PC gaming experience to a mobile device, which is fine. How are you going to bring the control experience to your mobile device. Carrying around a PlayStation controller is not something that's going to happen on a daily basis. I'm sorry. As much as I'd love to play whatever, Fortnite, the control experience, until you start adding console-style controls, which is what the game was originally designed for, it's very difficult to bring the real value proposition of cloud gaming until you actually have some kind of control system that actually makes sense. So it turns out that gaming as a major use case for phones, and especially for cloud gaming, you actually need to start talking about adding controls. Now, how do you add controls on a phone without adding buttons and other things? Fine, you introduce virtual buttons on the edges, and that's kind of, the ultrasonic technology is nearly ideal for this. Virtual buttons. So you replace, a lot of talk has been made about, power, volume, replacing the power and volume keys that are there. If you think about it, when the iPhone was launched back in 2007, 3 buttons still remained on the device: power and volume up and volume down. And why is that? Because we use those buttons the exact same way we use our TV remotes. We don't think about them. We pull our phones out of our pocket. We change the volume. We do not actually visually look for those buttons whenever we use them. The challenge is when you virtualize them is how in the world do you replicate that experience? Okay, and there are techniques that have been developed that actually can deal with the sort of the haptic location problem. And again, you can imagine when someone's trying to find the button, they're going to be pushing lightly. They're going to be running their finger up and down the edge. So if you know that you see a touch contact, but the force isn't high, you actually use the haptics motor to actually basically make it feel like you've hit the edge of a button. Okay, so virtualization of buttons actually can happen, and you can create a user experience that is comparable to the existing kind of physical power and volume keys. Having said that, there are a large number of people who will die on the hill before they get their physical buttons. Okay. From a phone manufacturer standpoint, one of the big issues here is that those physical buttons take up an incredible amount of volume actually inside the phone. Okay. And again, we are so space compromised that to the extent that if we can virtualize the power and volume keys and recover, let's just say 10 cubic millimeters of space, we will do that. Okay. So like it or not, actually, I think the real motivation actually for virtual buttons is not necessarily having a fancy sensor to do this, is that we actually may be forced to go here actually because we're out of space. Okay. And then the last one is around use case, which is grip detection. Okay, so left-handed, right-handed operation, I can actually move the volume key for a left-handed person. Okay, just simple little things like that. Actually, the other really interesting one was one phone that actually launched with a grip detector. Actually, instead of using the accelerometer to determine screen rotation, they used how you're holding the phone to determine whether or not I should rotate the screen. So if you're holding your phone like this, you shouldn't rotate it, even if you're lying down in bed. If you're holding it like this, yes, you should rotate the screen. And so grip detection actually, again, is a far better input variable to figuring out, should I rotate the screen or not, than gravity. We're using gravity right now because that's the only thing we could really figure until we had a grip detector. But at the point you can do grip detection, that is actually the right input variable. As one of those people who uses their phone lying in bed, believe me, it's a big deal. So with that, so have we reached peak sensors? As I said, new sensor hardware in these highest volume devices. And I emphasize highest volume because I was talking to someone about this right before this talk. The cost of developing silicon is extremely high. I mean, and it's getting more and more expensive as every year goes by. So you cannot, whether or not you like it or not, you cannot afford to ignore 1 billion units a year. You have to think hard about, can you find an entry point into a 1 billion unit a year market, okay? But it is getting exponentially harder to get into those platforms, okay? We're seeing a tremendous amount of innovation around existing sensor reuse, fusion, new modalities, things like that. Again, I think thinking hard about the algorithms and the IP and the systems actually that make this kind of sensor kind of possible is actually super interesting. And really the area we're seeing, I think the greatest growth are these, right? Ambient, health biometrics, and enhancing the HMI. And yes, thank you for your time. Sorry.
No?
Are students queries, posers?
This on? Can we get, is this mic on? No? Heidi, is your mic on?
Is it on?
Yes. Yours is. All right, I'll stand.
Hi. You mentioned, the atherosclerosis affecting the blood pressure wave, and looks like Apple's already working on AFib detection. What's your perspective on, looks like the raw data is already there. What's your perspective on these devices going from less informational health to more diagnostic devices?
I think it's going to happen. I think that's, I joke that, we've got to take our health devices from being toys to being kind of, clinical metric, right? And I think it's even beyond FDA certification. FDA certification, there's some interesting loopholes around that, right? It's really about, can we get to a, if your device is telling you, yes, you have a high blood pressure problem, you will go to your doctor, and yes, that diagnosis is accurate, right? Even AFib detection right now, one of the big challenges for AFib detection is, okay, fine, we've diagnosed you have AFib, now what? Right? So the single lead ECGs that we've got actually in watches and other devices are great for diagnosing AFib, but what's the next step? Right? So, can you get a 12 lead ECG into a watch? Kind of hard. But that's kind of where it needs to go as well. So really the frontier, I think, for health sensing is going to be around how do we get to a point where it's clinically helpful, right? It's no longer just, oh, hey, I measured my blood pressure, great. Yes, my blood pressure is tracking correctly, I'm taking statins, the statins are working, and so how do we improve our health by doing that? I think that's a super interesting area.
Hi, thank you very much. Very nice insight. It's maybe a naive question. You were mentioning that all those new features, well, they're all drawing powers and even more and more. Mm-hmm. Is there any need or any, could it happen that the energy harvesting would be implemented? Or is it like it's drawing too much power anyway, it's out of, like from kinetics or maybe the electromagnetic signals all around, there's so much power everywhere. I'm wondering, what's your thought?
So there's been a lot of discussion around harvesting actually for things like UWB beacons, Bluetooth beacons, things like that, where it's, and it may be that, yes, we do end up with a bunch of supercapacitors alongside of our batteries and you energy harvest. So for sensors that are running longitudinally, right, that have to wake up once every 5 seconds, take a reading and then go back to sleep. Yes, it's quite possible we will end up harvesting power actually to run those sensors. I mean, for example, the IMU. The accelerometers are now down sub 10 microamps in their, quote, rough or lower sensitivity modes. We're starting to see sensors get to a power level where, yes, we can significantly, meaningfully talk about energy harvesting. Having said that, a piezo harvester or things like that, let's set the lead question aside for a moment. The problem is they're taking a volume, right? So this becomes a really interesting trade-off.
Thank you.
Marto's got one up there. I'll run it up to him.
Thank you for the talk. Very, very interesting and inspiring. Eduardo with ST Micro. The question that I have is, do you see still in 5 years from now the phones being the highest volume platform, or do you see anything on the horizon that might replace the phones?
He's going to have even more sensors on his body next year. Where are they going to be?
I will give, I think that, okay, so as an anecdote, I had a conversation with a VP actually out of Nokia in 2006. He was absolutely convinced that Nokia will be there forever. There's no possible way. Power was the only thing that was going to differentiate phones going forward. And, yeah, Nokia was going to be king forever. 12 months later, the world changed. So there's a lot of folks who are actively trying to replace the phone. Okay, there's a fourth platform that I have no idea whether or not it's going to happen, right? I mean, obviously our friends at Facebook, Meta have made a lot of noise in the last 6 months about this. The so-called face computer. If you ask my sort of personal view on it, and again, this is not a Google statement, this is just me personally. The power and size constraints before that particular platform ends up seeing mass adoption is incredible. I mean, it cannot be any heavier than the glasses I'm wearing right now. Call it 100 grams, okay? How much battery can you get out of that? How much, just even driving the display. There are startups right now who are actively working on contact lenses. Okay, there's an RF, they've got an RF transceiver, a battery, and a display mounted inside contacts, okay? If you think about the replacement of the phone, there's actually 4 major pieces to replace a phone, okay? You need to be able to hear something. Fine, we have hearables. You need a small display of some sort, or some kind of sensors platform, right? So you got a watch, that's 2. 3 is actually the visual interface, okay? So the head mount device is number 3. And then number 4 is actually what is your input methodology? Okay, so fine, I'll acknowledge Apple has 2 out of the 4. Okay, I mean, they're dominant in hearables, they're dominant in the wearable, fine. No one's got a good answer actually for the head mount. And actually, as much as everyone's been trying to work in the head mount, no one has an answer of what is the replacement for a touchscreen in virtual space. How do I write? How do I type? Right now, we have no technology that allows me to do this in virtual space and type at speed with any accuracy. I do not know of an answer to that problem. Been working on it. But there's no good answer. So until you replace the phone, you actually have got to actually have all 4 pieces. And actually, I would say number 4, which is what is your high accuracy input method? That's the one that actually I don't think anyone has an answer to. So until you have an answer to number 4, I think that's the reason why everything you're seeing around the VR, AR space is around gaming. Not super high input, I mean, if you play Beat Saber, you know something. It's not a particularly high accuracy input methodology if you play Beat Saber on your Oculus, which I do. So anyhow, I mean, if you really think about what it's going to take to eliminate the phone as a platform, you have to solve all 4. Sorry.
Hey, Christian Peters from Bosch. Very nice talk. Thank you very much. I have a question about the HMI. So you mentioned you have now this virtual button, and I think you did tremendous work with your previous company to really push the bar in this direction. What is your opinion about morphing surfaces so that people can start feeling from a previous flat surface, now they have a forming button, they can feel it, so they don't have to look anymore?
The challenge there is there's a huge rel problem with that, right? I mean, okay, let's set aside, oil-filled bladders for a moment, right? There was a startup that actually was working on that, right? I mean, there's significant rel issues actually to anything that can deform and morph. If nothing, let's think about a foldable phone as a morphable device. Just think about it in those terms for a moment, right? The rel challenges just around that hinge are astounding. I mean, you think about what Samsung has to deal with, right? I mean, the worst use case, if you think about like a foldable, is I've got the device open, but it's face down. It's on the couch and I sit on it. Okay, what happens, right? I mean, there are some huge challenges from a rel standpoint to these morphable devices. So the value proposition of being able to kind of physically morph the device like that, I think, is relatively small compared to trying to invest in, haptics, tactile, other things to basically make you think that you're pushing or touching something that's got a surface.
Last question, Dave.
David from G Research. You talk about a lot of personalized data, biometric. Just wonder how do you address the concern about security, privacy of the society might have, right? How the sensor community can help that.
Let's just say for me to do a biometric study in and of itself, the number of legal loopholes I have to go through is nothing short of astounding, right? It's a key issue. I mean, there's no question that the best security is to actually make sure that data actually never leaves your device, okay? I mean, so having things like, you know, ear canal measurement, right, where that data never leaves, let's just say, your earbud, okay, and that there's a secure authent between the earbud and your phone. So long as the data stays local, that's probably about the best you can do, okay? Not a fan necessarily of cloud authentication. There's just too many opportunities for the data to get lost in some weird way, shape, or form. But this is really more of a policy / system standpoint. And I mean, there's another whole school of discussion, which I didn't have time to talk about, which is moving more, you know, as much as we talk about things going into the cloud and sensors being driven by the cloud and all that, actually, I'm actually of the opposite mindset. I'm actually of the, we need to move more things into the silicon actually in the sensor itself. Not only for the issue you brought up, which is security and data security, biometrics, things like that, but from a power standpoint, there's a huge penalty to waking up the application processor. Waking up the SoC is actually a really power-hungry step. If you just think about just the amount of time and power it takes to wake up the crystal is a non-trivial amount of power, it's a non-trivial amount of time, right? So actually moving to a model where we're not waking up the AP to go service the sensor is actually a good thing. So, you know, one of my little pet peeves is that I think touch sensors need to go from being a touch sensor to being a gesture sensor. Instead of just indicating, hey, I saw a touch at this position. No, I saw a swipe. Okay, you don't have to wake up the AP until there is certainty around that, yes, there is an action here that the AP needs to go be aware of. Right now, just you accidentally brush your phone, yeah, it'll wake up everything, right? If you say, yes, the user definitely did a double tap, at that point, wake up and report that a double tap was seen at this location, right? So that's a really different mindset around what we're seeing right now for kind of sensor development. Putting more brains into the sensors actually ultimately may be the right solution from a power standpoint. But again, that's just my personal opinion. What do I know?
Sam, fantastic talk. Let's thank the speaker one more time.